All right, let's take a look at today's lesson. So we're looking at interpreting graphs of functions. What this lesson, again, we're continuing to help get you ready for and build the skills that will make you very successful in calculus. We do this in calculus a lot. We take graphs and we read information off of them. So this is just practice on reading information off of graphs in various different ways. So what we have here is we have two different graphs. We're told that f of x is the dashed line, so let's just go ahead and label that, and we're told that g of x is the solid line. Okay. These numbers here on the number line are a little bit hard to read, so you might want to write over them. You know, that's 1, 2, 3, and so forth. They're just a little bit hard to read, but we will work with it. So the first one, finding f of -1, we simply need to locate f's graph, which is the dotted line one, and we need to go to -1 and find that y value, which would be 6. So pretty straightforward. F of -1 is 6. On the second one, it's asking us to actually do f of 3 plus g of 3. That's what it's asking us to do. So what we'll need to do is we'll need to go over, so we'll look at f right here and go to 3. So f of 3 is this number, so that's a -6, plus g of 3. So g of 3 is that number, and that's a +6, so that nets out to be 0. Okay. On number 3, just another configuration, finding those y values. So we're going to do 2 times f of -4. So f is our dotted line, so we're going to follow over f of 4 right here. So that's what, a 6 minus. Now we look at g. G is the solid one. G of -6. G of -6 would be right here. What is that, a -2? So I have 12 plus 2, or 14. Okay, is everybody doing okay so far? I'm not moving too fast, am I? Okay. All right, so on number 4, we have several things to do. I'm actually going to have to place the numbers in a quotient. So let's do g of -8. So here's g of -8. What is that, a -2? And then we have f of 0. That would be 3 all over g of 0. So the solid line at 0 would be at 4. So we do those computations and we get 1/4. Okay, so hopefully that's fairly comfortable. You'll have all kinds of problems like that where you're asked to do different operations with numbers that you're taking off of the graph. Okay, so let's look at number 5. Here we want to find the values of x such that g of x is 4. That g of x is 4. So g of x is the solid line. One way to do this would be to just draw a horizontal line at 4. You know, that's one way to think about it. So we want to know where g is 4. So everywhere the solid line crosses that line, that horizontal line, is where g is 4. So here and here, let's see, so it looks like it's 4 right here at 0. And it's 4 right here at 4. So at x equals 0 and x equals 4. Let's say instead they asked find the values of x such that g of x is larger than or equal to 4. Would we be looking for just one or two numbers? No, probably not. We'd be looking for an interval. Right, so g of x is the solid one, and it looks like it's bigger than 4 right here, right? It's bigger than 4 starting at 0 and going to 4. Okay, so that's what that question would look like. You'll see some like that too, where we're looking for intervals instead of just specific numbers. Okay? All right, number 6 gives us p of x. P of x is x squared plus 2x minus 13, so it's a quadratic. And it says for what values of x is p of x equal to g of negative 3? Well, we need to find out what is g of negative 3, and then we'll just kind of go from there. Let's find out that first. So g of negative 3 is right there. What is that, a 2? So basically it's asking us for what values of x is our p of x equal to 2. Well, I don't know. Why don't we go ahead and set our p of x equal to 2 and then calculate that? We'll figure that out. So replacing, p of x with 2. And then we have to think back to, our years of working with quadratics. If we want to know what x is, we would move everything to one side, and then either, hopefully we'll be able to factor. If we can't factor, then we'd have to do quadratic formula or some other technique. So let's try to factor first. So the back sign is negative, so our signs are different. So what do we have? A 5 and a 3. Yep, that works. So the values of x where this would be true, where p of x would equal g of negative 3, would be at x equals 3 and x equals negative 5. Okay, we okay so far? So we are taking information off of the graph and using it in various different ways. All right, let's go to the next page. We're going to use the same graph on the next page, but just ask different questions. Okay, so again, let's label it. Our dashed line, let's see, f of x is the dashed one, and g of x is the solid one. This is our same picture for diagram from the previous slide. We want to find the values or intervals of values that follow this. So on number 3, actually, I had it was a duplicate of number 1, so go ahead and change that on your notes to a greater than. I had an equal there, so let's just fix it and make it greater than. All right, so let's look at number 1. We want to find the values of x such that f of x equals g of x. So we're looking for where are their y values the same. Where are the y values the same? So we're looking along here. We see right here their y values are the same, and right here. That's where their y values are the same. That's only 2 places, right? So let's find those x values. Now on this particular one, they don't cross exactly at an integer, and that's okay. We're just going to estimate. I encourage you to just estimate in halves. Don't get any more precise than halves. So if it falls in between, 2 integers, just go to the half. So since it's a little bit to the left of 0, but not quite at -1, we're just going to call it -1/2. So we have x equals -1/2. The other location over here, that is an integer location. So 1, 2, 3, 4. That's at 9, so at x equals 9. And those are the 2 locations where the y values of those 2 functions are the same. Now we want to look to see what values of x is f of x smaller than g of x. So we want g of x to be above, g of x is above f of x to make that true. Okay, so g of x is the line, and is that true over here? No, g of x is below f of x, so we just need to keep moving along. Looks like right here, f of x is the dotted line, so starting at -1/2 and going to, not because they're the same at 9, I can't include 9, right? We want it to be greater, we want f to be less than, not or equal to. So I've got to kind of stop, and then it actually, f of x, the dotted line, is still less. So let's look at this. Notice how g of x stops. It stops here. I mean, f of x doesn't. You see the arrow, it keeps going, but g of x stops. When we're comparing these, we only are able to compare them where they exist. right? So when one of them stops existing, we have to stop comparing. So here at this, what is that? 1, 2, 3, 4. At 11, g of x stops, so I can only compare to 11. Now notice how I didn't include -1/2 or 9, but I did include 11. Why would I include 11 and not -1/2 and 9? Do we see the significance there? Exactly, because at -1/2 and 9 they equal, but at 11 it really is less, isn't it? It's really less. It's not the same. So I should include 11, and that's actually as far as I can go because this stops. Okay, so just kind of be careful which type of bracket you're using. You can use, interval notation like this, or you could use with, inequalities. You could say -1/2 less than x less than 9. That's fine. And 9 less than x less than equal to 11. Either one of those is acceptable unless the instructions tell you to do one way or the other. All right, otherwise just pick the kind of notation you like the best and just stick with it. Number 3 wants to know where is f of x bigger than g of x. So we're looking for the dotted line being bigger, which is over here on the left. Of course, it just starts right here at it's -9, and it actually doesn't even equal -9, does it? That's a hole there. So we would start at -9. We wouldn't include -9. And we would go to, looks like -1/2. And they're the same there, so we can't include that. And it doesn't look like there's anywhere else where the dotted line is above the solid line, right? So that's really all we have right there. Okay, we okay so far? Okay. Number 4, the values of x such that g is increasing. All right, so let's focus on the solid line one, the g one. Increasing, the way we read increase, decrease, I'll just remind you, as we're reading like a book from left to right, when we start rising, that means it's increasing. Right, the y values are increasing. So as I'm looking at g of x, it starts increasing right here at -6. So it starts increasing at -6, and it increases till it hits here, which is what, 3. Okay, so we go from -6 to 3, then we decrease. We have one. Oh, good question. So actually, you probably think mathematicians just get along with everything, but actually for increase, decrease, this is one thing they argue about constantly. Right? So some mathematicians believe that the point where it starts increasing actually is included, and some mathematicians believe it's not. So you can actually, on that particular thing, you go either way. It depends on which camp you align with, which mathematics camp you align with. That's, I know, it's a big problem, really big argument here, but I, kind of go with the parentheses, but it's okay. I can see both ways. So we would go from -6 to 3, and then the next time we start increasing would be over here. Right? What is that? Is that 9, 2, 4, 5, 6, 7, 8, 9? From 9 to, let's see, 11. And that's where g of x is increasing. Okay? And the last one, find the values of x such that f of x is constant. This caused a little bit of trouble earlier this morning. Let's be sure we understand what that means. F of x, that's the y value of f of x, right? F of x, where is it constant? What that means is, where is it the same y value for a period, for an interval? Where does that y value repeat for an interval? What this is doing is getting us ready for evaluating velocity graphs and such. So where is our, f of x constant? What would we be looking for? We're going to be looking for a horizontal line, right? That's what we're going to be looking for. So let's look at f of x, which is the dotted one, and we see that this location right here, here's where it's constant, right? This is the y value keeps repeating itself over and over again right here at 6. The y is 6, and so forth. So we're actually from here to here. So let's see what those numbers are. What is that? A -6? 6. Yep. So from -6, and it can include that, right? because it is negative 6, excuse me, it is 6 at negative 6 all the way to negative 1. And that's where we are constant. Okay, or if you wanted to write it in interval notation, it would be look like that. Okay? We okay with this lesson?